You ready?
Yes.
Welcome to this TD Synex podcast, where we'll talk about sustainability. It's a very broad subject, but today we're going to focus on just the network part, or focus mainly on the network part. My name is Geert Kuiken. I am a solution architect at HPE Belgium. I'm also the ESG ambassador. And today I'm joined by Tim Thijssen, who will introduce himself.
Yeah, thank you for inviting us, I would say, Geert. And of course, TD Synex, thank you for inviting us. Well, I'm Tim Thijssen. I'm the pre-sales team lead for the networking department within HPE. So HPE Networking, as it's called today, with the combined business of Aruba and Juniper, of course. And today we're indeed going to talk about sustainability in general, but really a little bit more focused about how we do it from a networking point of view and how we can actually build out solutions that enable new use cases, more sustainable use cases, and how it can actually also help you from a customer point of view to reduce the total amount of power you spend on the networking.
So power consumption is obviously one of the things that springs to mind when you talk about sustainability. Is it the decision factor for customers when they go to buy stuff? Do they look at power consumption as a buying criterion?
Well, you see it more and more coming up into the RFPs, like I would call them, I would say, or the questions we get from partners, from customers from there on as well. We see questions regarding power consumption, how you're meeting your sustainability goals, not only from a vendor perspective, but also from an integrator or a distributor, I would say. So we see more and more questions regarding that topic, and I think it's quite an important one because traditionally we think about everything to do within the data center, the traditional IT equipment, but not always we think about the networking part of it as a way of, well, we should take that in scope and we should really rethink our strategy, how we manage everything regarding sustainability, I would say. And this is really a major new way of thinking that was introduced since we actually started with the mobile first approach. And I think the mobile first approach is a really great start of actually starting with building actually a sustainable design for the network. So the mobile first design, like we call it, or in the common terminology, it's also a Wi-Fi first approach, is actually to change the way we connect to the network. Because in the past, well, I would say 10, 15 years ago, or even sometimes today, like a lot of companies are still using the network, well, they pull cables to every desk. So to every desk, they pull full 1-2 Ethernet cables to make sure everything is connected. One for the docking station, one for your traditional PC, maybe one for a third-party device from there on. And they didn't really think about a mobile-first approach. But if we really think about the amounts of copper, the amounts of plastics that we're actually introducing just by pulling those cables, the amount of man-hour we're actually using to actually install all those equipment, it's quite a lot. So the first part about the sustainability is already in the design of the network. And the design of the network, it starts with a Wi-Fi first approach. And in this way, if we do that Wi-Fi first or the mobile first design, then we can actually reduce the amount of cables that we're using onto the network. And this is by leveraging a full Wi-Fi only approach. This means you no longer have any kind of cables from the network running into the desks. And this saves a huge amount of plastic, a huge amount of power, because, well, those ports also consume power from there on. And it also enables, well, a digital workplace in a case, because, well, people can start moving around from desk to desk. They can start doing goals on Teams and also while walking around the office. So it's not only a sustainability part, but also a way of actually embracing a new way of working in that case. So it's part of a larger scope, I would say.
Yeah. So the architecture plays a role, and also the choice of equipment.
Yes.
And I believe that within HPE Networking we have some specific power management technologies for our wireless portfolio called Deep Sleep. Can you elaborate on that a little bit?
Yeah, indeed. So we have a couple of technologies that help you reduce the amount of power, well, you're actually using to manage the network. And one of them is actually, like you mentioned, the deep sleep mode. It's a functionality we introduced somewhere, I would say, in 2014, 2015, where we thought, well, we're going to schedule the network basically to turn off at a specific time and put the access points in some kind of sleeping mode. The only thing that we actually saw is, well, it's kind of statically, that environment. It's not really smart, it's not really clever, and it was holding back a lot of people to actually use that functionality in that case. So we actually rethought it. How are we going to automate this this kind of behavior. And this is where machine learning and AI really comes in. And this is where AI and HPE are perfectly positioned to build out a solution to actually leverage the deep sleep functionality within the AP. So what we're actually doing is we're looking into an office environment or a campus environment or really big environments. And during the days, most of the people, well, they come to work, they connect their devices, they connect with the smartphones, their laptops and so on, and they're consuming all the wireless signals. The wireless is being broadcasted at full power, or the power that's being configured at those access points. But as soon as the people are actually going back to their home, well, those APs are still blasting in full power, while there's nobody left at the office, or maybe a few workers in some spaces are still at the office. So what we actually thought is, if we now dynamically look into the environment and actually use AI and machine learning to actually analyze the environment and see when people are coming in and see when people are leaving, then we can also reduce the amount of power into those environments. And for example, we start with turning off a few APs, putting them in that specific deep sleep mode. But really, if it goes to later in the night, for example, and nobody is anymore in the office, well, we can reduce the whole park by around, I would say, 80% of the APs. We can actually put them into a deep sleep mode and reduce the amount of power. And if you think about, I think it's around 100, 200 APs. If you look at just at a smaller environment, so it's not a huge environment, we save on a yearly basis around 18 the amount of CO2 that we're exhausting, I would say, is compared to around 18 trees that we need to be planting that are actually full grown, I would say. That's the amount of CO2 we're actually reducing with this technology. So it's a huge impact on a full grown tree, I would say. We need quite a lot of full grown trees. And we talked about it before the podcast, I would say. Yeah, it's a tree that's being planted, it's not immediately grown, it's not the same level of CO2 that it's actually reducing. So that's quite a big impact. So the deep sleep mode, it's actually a quite useful functionality that we're leveraging within the access points to actually reduce the amount of power we're spending on the network, I would say.
Yeah. Okay, sounds good. So every tree roughly contains or stores about 20 to 25 kilograms of CO2 every year. But of course, bigger trees, older trees store more than younger ones. So it's important if you plant trees that they actually last for a long time. I think that's clear too. But on average, 20 to 25 kilograms per tree. So 18 trees is a useful number. Now, deep sleep is an HPE Aruba term. Does it also exist in the Juniper portfolio? Because as you know, we are integrating the Juniper portfolio into HPE networking. So is it an industry standard terminology, or is it something specific? And is there an equivalent in other vendors?
Unfortunately, there is no standard there yet. I think other vendors might look into similar technologies. They have similar ways of actually reducing the amount of power spent on the APs, or they will do it on a statically basis. Like, for example, other vendors do that specifically. But the problem here is if you move into a static environment, it's not really changing as fast as we would require. And they also look at it from a different perspective. While we have the deep sleep mode, we also have a second feature within our access points, which is called intelligent power management, which basically looks at the power being provided and then adjusting to that. We're actually disabling or enabling in X amount of features. So we're actually taking a phased approach on the power management of the APs as well. And this is the first part, the intelligent power management. For example, if you see a limited power flowing in, this is something other vendors are also embracing. This is something they have. But the deep sleep mode, this is something not yet that common with other vendors. Mm-hmm. And I think, if I look into examples from the past, I had talks with universities, with other big really big campuses within government, for example, and we looked at the power that actually those APs are actually consuming. It's a huge amount, especially when we were looking into those environments with more than 10,000, 16,000 APs. Yeah, that's quite a lot of power being used for no reason, because there is nobody in the office anymore. So I think this is a first step in moving into the correct direction, and I think it's something that I hope the industry will adapt to on a later stage from there on as well.
Yeah, interesting. Of course, power management is not a new concept in itself, but saving 80% of power compared to the steady state, full-blown, everything is on, that's a big impact. Now, To broaden the debate a little bit, IT also consists of compute and storage equipment. And of course, power management is not new in those areas either, particularly in servers. It's been around for a while. There are power management features and settings in the server's BIOS that will make sure that it consumes less by, for example, reducing clock speed of processors, and that can make hundreds of watts of difference for a server. But of course, switching off a server, as you do with some access points, is tricky because the applications running on it, of course, will stop working. Mm-hmm. Now, there are some automation technologies there as well, particularly if you virtualize. You can use the hypervisor level to migrate virtual machines from one server to another, in effect emptying one server, and then you can automatically switch it off. And when the system detects that there is more load, you could reboot that server and again move virtual machines to it. So in the server world, you can do some power management. In the storage world, it's completely different because, of course, in a storage box, all disks are used and all disks contain data. So even a partial shutdown of a storage box will inevitably mean that your data is no longer accessible, and that's, of course, a no-go. So power management in the storage world, it doesn't really exist. The research focuses on using power-efficient components, as you do in networking as well, as happens in storage as well. Yeah. Power efficiency of components is something extremely important. Power efficiency of the power supplies is also extremely important, and that's where the legislation around Europe is putting down rules for minimum efficiency levels. So we are moving in the right direction in any case. Mm-hmm. Of course, if you look then at public cloud, many workloads run in public cloud. And there you'd think that the useful actions would be to, as you do at home, switch off the lights when you're not in the room. So when the application is not being used, you switch off that workload in public cloud. And it is perfectly easy to do that, particularly for stateless applications, where there is no real data in that applications. But many people don't do it. Now, our human work life is typically 30%. We work 8 hours a day and do something else for 16 hours. But if your workloads are on 24/7, and now for some workloads that is reasonable to do that, but for many workloads it is not necessary. And if they are in public cloud, you could say, okay, I switch off my resources when I don't need them. That would equate to a 2/3 energy gain. So that's a useful step as well. You just have to think about doing it and implementing it, and automation tools exist for that. So the infrastructure absolutely is important, mm-hmm. But let's not just talk about IT. We're in a beautiful building here, and buildings are being filled with sensors. We call them smart buildings. We talk about smart cities. How is this networking automation relevant for that world of smart everything?
Well, I think that's a great question because, a lot of our customers, they think about smart buildings. They want to evolve towards smart buildings, but they don't know how to approach it. Is it only for a newly built building, or is it something they can retrofit? And I think this is something where, from a networking point of view, we're actually an enabler in that case, because we can both enable it in a newly built building, and then we start basically already from the design part of it. Then we think about how do we heat the buildings and so on, but also to retrofit those buildings in that case, because if we're retrofitting the buildings, then we need to break out the ceilings, we need to pull new cables, we need to isolate those buildings and so on. But a lot of people, they forget there is already something, IP connected over there, and that's actually basically the access point. And the access point of Aruba, we don't see it anymore as just a wireless access point, but we see it as an IoT gateway. And the IoT gateway specifically for smart buildings is quite a valuable asset, because if you think about all the extra cables each time for one specific IoT protocol or one specific IoT gateway, we need to break open the ceilings, we need to pull new cables again, install new gateways from there on. It's quite an expensive investment if you look at it from that point of view. But again, it's a lot of plastic, a lot of copper waste that we're introducing for something that's basically already in place, because that IP, it speaks a lot of IoT protocols. It speaks Bluetooth, it speaks Zigbee, and it has a USB port where we can introduce any kind of exotic IoT protocol that we're not supporting yet, or maybe is something that will break through into the future as well, to retrofit our existing APs. And by leveraging the wireless infrastructure which is already in place, we can start moving into that smart building space, either newly built or an existing build. And then we're starting to use the access point as an IoT gateway and start connecting multiple sensors onto the network via the gateway. And if we think about those sensors, well, we need to think in a little bit in a broad way because, well, there are multiple things we need to think about. We have, of course, the lights that are always on in a lot of meeting rooms. Then we need to think about heating, for example. We need to think about other types of spaces and so on. So we need to do integrations into multiple categories. For example, the easiest way would be to actually build in a presence sensor that's connected via the AP and basically detect, well, somebody comes into the office, we need to turn on the lights. A lot of times I see at existing customers, well, they introduced a new vendor, they pulled cables, they installed a new gateway from there on, and it's really proprietary, it doesn't integrate well into their infrastructure, nobody knows who it's maintaining. Most of the time it's a little bit facilities part of it, but if we can leverage that via the AP, well, it's again less infrastructure, and we can also make it smart in an easy way because we have a supported ecosystem within that IoT space, I would say, with multiple vendors that we actually support, and then we can start building out really smart building solutions by, for example, the presence analytics detecting that somebody is in, then we turn on the lights, we turn on the meeting room system, we start booting up everything, or we see, for example, it's being integrated with some kind of Microsoft Teams integration that we see, well, a room is being reserved at a specific point. Well, then we can start integrating with the heating as well, because we can introduce smart heating valves. And smart heating valves, they are quite interesting, I think about them. I think they're quite interesting, I would say, because, well, they actually use a part of the heating as a way to actually generate power to control their own valving technology. And in this way, they will see, for example, there is a Teams meeting being introduced, and they see that the meeting room is reserved at 10 o'clock. So before 10 o'clock, they will start heating up the room. And after that, the meeting is finished, they will actually reduce the valve. So less heating is being used, unless there are, of course, a couple of meetings in that case. And there are a huge set of new sensors flowing into the market space, even being powered passively. And I think that's a fascinating way of thinking about it. Like a lot of those sensors, they're actually being powered with a small solar panel that actually is extending the life cycle of those sensors. And we're talking about multiple years even, that they're being powered passively just by harvesting the light. And even the new type of sensors are not harvesting any kind of light sensors, but are harvesting radio waves and are actually using the radio waves to power themselves. Like there are multiple Bluetooth sensors now connecting into the space, and no sensors in general, I would say, that are using the power emitted by the radio waves to actually power themselves in this case. So this means they're becoming wireless in two ways. They're not only wirelessly connecting, but they're also being wirelessly powered in this case. So this, again, reducing the amount of cables even for the power up to those devices. So the whole smart building space is quite evolving quite fastly, but I think if we take that into account when designing a new Wi-Fi space, well, the total TCO of the total cost of operations and the sustainability part and the way of actually efficiently doing all the works, well, it drastically reduces the total amount of costs on the network and the total infrastructure cost, I would say.
Yeah, it sounds like real progress. So if I understand correctly, the access points, you can see them as a kind of the central nervous system or the backbone for a smart home, a smart business, a smart city. So it scales from very small to very large. You can put it anywhere.
Yes.
Yeah,
indeed. Like you have multiple type of use cases, I would say. You have smaller remote offices, like typically a smaller retail, smaller banking from there on. That, in retail, what you typically see is pricing labels. Pricing labels are, I think, a perfect example on how you can actually reduce the total footprint, because, well, those pricing labels, a lot of supermarkets, they're now embracing digital pricing and also digital stock management. And I think two really cool examples about that is actually, well, the first step that we actually saw was, well, we're reducing the amount of paper waste because they always print new labels. They need to hire somebody to put all the new pricing labels in the shelves, I would say. So they digitalize that process to make it a digital price. So if there is something becoming more expensive, becoming less expensive, I would say they just do an update from there on. But they're now looking into which products are on the shelves and what is actually the expiry date for those products. And based on the expiry date, they're actually going to do dynamic pricing. Because from them, well, if if the product expires, they need to throw it away. It's really a waste of food. And well, we know there is, in some countries, there is quite a lot of food shortage. So we need to rethink how we actually manage food. And I think those supermarkets, in that case, well, if they reduce the price, it becomes an incentive for a customer to actually buy those products in the supermarket. And this is enabled by those smart pricing labels. And the next step we actually saw supermarkets doing is actually by filming the opposite. They're actually filming the other hallway. They're looking at the inventory and seeing which products are selling more quickly, fastly, I would say, and which are actually staying in the shelves as well. And they're using that to actually build out their supply chain as well to make sure they don't overstock their items and they need to throw less food away in that case. So it's actually the IoT part of it. It's something we don't think about, but it's actually changing so many aspects, even in the supply chain, even in the food space, I would say. So I don't think the IoT part of Aruba is making sure you have less food waste, but it's a small piece in a larger puzzle which enable huge types of new use cases, I would say, new types of solutions that make sure we meet those sustainability goals into a bigger perspective as well.
Yeah. We used to think about data. It's important to store it and protect it. It's important to calculate, but it's also important to send it from A to B. And today in businesses, that's happening more and more. And it's good to see that we can do this sustainably, because the more data you move, the more energy you need to move it. Mm-hmm. So all these sustainability technologies of reducing the cost and reducing the energy required to move data around really helps business and opens up new use cases and makes it affordable to implement those scenarios. Is there anything else we've forgotten we can talk about?
I think, an important one that we forgot about, and I think it's a great solution within the overall HP, because you already mentioned servers, you mentioned storage, we mentioned the networking part, but everything is being managed via the GreenLake portal. And I think in the GreenLake portal, there's also something about the sustainability dashboard, which of course you know way more than me about. So I think that's something I think it's important to share as well, that we do have a sustainability dashboard where we from the networking feed a lot of information into it. Mm-hmm. But maybe you can give some insights in what we do.
Yes, all the equipment that HPE sells is optionally or automatically managed through the GreenLake portal, which is a cloud-hosted dashboard. And one of the things that it will show back is the power consumption of that equipment. We do this for storage, we do this for compute, and we also do this for access points. And it shows you in terms of watts, how much you consume. It also calculates what this costs you based on your actual electricity costs. And it also calculates the CO2 emission equivalent. And it keeps those data for as long as you like, and it's always there. You can export that data into reporting tools that companies are more and more being asked to implement, because the European legislation says you will report your CO2 emissions. Particularly larger data centers today have the legal requirement to report this. And what is coming is that they will have a legal requirement to prove that they are actually improving over time. So real-time measurements over time are extremely important. That's why we build them into our technology. The technology will actually report power consumption, so we can use that data and calculate with it. And of course, we provide a dashboard that allows people to use it and see it and view it. And with our OpsRamp technology and observability agents, we can do this for third-party equipment as well. So it doesn't have to be just HPE. Any data center can be instrumented to report its power consumption to that sustainability insight dashboard that we provide. So really good.
Yeah, indeed. And I think, if partners and distributors, if partners in general, they have some kind of sustainability questions, I think they can always reach out to us. But I think there is also a great website on the HPE website, specifically tailored to the sustainability part. I think there is a report somewhere.
There is a group within HP called the Living Progress team, and Living Progress is our name for ESG. So the sustainability approach is handled by that team, and there is a complete website. So if you look at the HPE site and look for Living Progress, you will find a yearly report, among other things, about 100 pages, which charts our progress and our status every year on things like our own operations. How green are they? How are we making progress in terms of running sustainability, our own operations, sustainably our own operations? It also talks about the wider scope of ESG. There's a social and government, not just the environmental. Social and governance, not just the environmental part of it. And on the social side, I like to call that the fair trade principles. We will do business with suppliers who respect human rights, who pay people fair wages, who don't use dangerous chemicals or unhealthy procedures, no child labor, and those kind of things. So that's in the charter. For people who want to work with us, they need to comply with our charter in that respect. And the governance means that we actually track the progress of our suppliers as well as our own, and require some reporting from their side to know that we are still on the right track. So that's I think it's a very broad approach. From A to Z, we try to look at all aspects of sustainability, not just the power consumption and the legal stuff that everybody has to do, but we try to go one step further. This is probably why our mission statement is we advance the way people live and work. So you can look at this in a very green way. Everything needs to be sustainable, so the Earth is a better place when we leave it than when we found it. You can also interpret it in a very technological way, that we build good technology that makes people's lives easier by the modern, latest, greatest, fastest, most beautiful access points you can imagine. So it's a very good concept, I think. Yeah.
Yeah. Okay, I think that was a great introduction to what we do around everything to do with the networking, and then everything we do a little bit into a bigger picture of it, what HPE does regarding sustainability. So thank you here for inviting me. And
thanks for your input. It was very interesting. Thanks.
Okay, and let's talk soon, I would say.
Yeah.